Hello students, how are you? I hope that you are all doing well. Today we will continue our lesson 19.3 simple circuits, but we will study the second part of the lesson, Kirchhoff's rules. We will be explaining Kirchhoff's rules and also solving problems involving Kirchhoff's rules. Kirchhoff's rules are very important and essential for any student who is studying circuits and electricity. Kirchhoff is a German physicist who formulated two important rules that we will be focusing on today, the loop rule and the junction rule. We will give the symbol LR for the loop rule and JR for the junction rule. Let us start by the loop rule. Loop rule simply states that across any loop in any circuit, delta V equals 0. What's the meaning of that? Here you have a circuit with actually two paths, but we will consider only one loop. So this is the first loop. You can also take or consider the outer loop without this part, without the part that has R1 and R2. But for now, let us consider only the red loop. Loop means a closed path. For sure, potential is rising here, or the battery is giving electrons some energy, and this energy will be lost in R1 and R2. So whatever is gained as energy for the electrons here from the battery will be lost in the resistors. So it is just one form of conservation of energy. The battery gives energy to the electrons. The resistors make electrons lose this energy to other forms. Resistors may be any devices or appliances and so on. So here, if I have, for example, an increase of 9 volts, okay, 9, then for sure across R1 and R2 I will be losing the 9 volts. We can also say compare this to the loop during hiking. For example, you start at one point, you go through ups and downs and then return to the same point as if you did nothing. So delta V equals 0. Okay. So let us assume that electric potential due to the battery is increasing by 9 volts. As the charges travel, the electric potential drops at R1 5 volts. So for sure, because I know that energy gained is equal to energy lost, then the amount lost in R2 will be just 4 volts. If I add 5 volts and 4 volts, this will give me back the 9 volts. So if we apply Kirchhoff's rule here, the loop rule, delta V equals 0, positive 9 minus 5, energy lost, minus 4, again energy lost, will be equal to 0. It's a very simple concept, but it will be very helpful for us in solving problems. Now the second rule is the junction rule, which will be focusing not on potential differences but on currents, and it will be a form of conservation of charge. Here I have a circuit with a junction. Point A is considered a junction where I have two branches or two ways for the current to pass through. Point B also, as you can see, is another junction. The junction rule says the currents in is equal to currents out. So total currents in is equal to total currents out of a junction. So here, currents entering point A is just I1. I1 for sure will be equal to the two currents going out of the junction, which are I2 plus I and I3. Look at, this is at A, at junction A. Let us take a look at junction B. I have two currents in, which are I3 plus I2. Can say I2 plus I3, doesn't matter, these are going into B. What is going out? Only I1. And yes, as you know, that I1 is equal to the two currents, the two parts, I2 and I3. So this is called the junction rule. Application here is very simple. Now we will be solving the sample problem related to Kirchhoff's rules. Solving problems related to Kirchhoff's rules has a special technique. You need to pay attention to the steps that we will be following. You might feel that it's a lengthy procedure, but once you are practicing well on it, practiced, you will find it very easy and enjoyable. Please write down the notes in your notebook, including title and objective and sample problem. And if you have any question, feel free to ask me.